through this computer. So 3D printing now is the second component. It's not necessarily more difficult. I wonder if I have some of the complex geometries are in this file. Do you remember what?
Is there anything at the top?
Maybe it didn't come.
Or at the bottom? I don't see anything.
Maybe they didn't come. Well, I can bring and take a look here.
Can you just like isolate and run it? Like select something and.
Yeah, they're not here. That's why.
I think there was a. To go back. There's like a.
So let me see. Okay. Well, wireframe. Here, let me just select a couple of the monsters or one. Then we'll all right. So those are, what are those? This is the graphics. Those are imported
Walls.
elements. Huh? Oh, they're walls.
They're imported categories, objects, styles. I don't know. That's where they are.
But they're, you hit them one by one, or?
I import them one by one, yeah.
Hide them now. Maybe they're there. So we don't see it, but it's there. This is one of the monsters Sarah is working on. In theory, you will have whatever you want to 3D print in the view, and we will do the same as we did before. Now, these ones are interesting to 3D print because they are irregular shapes, and you wouldn't be able to do this otherwise. No? So we'll go File, Export, Cut. I mean, they come from Rhino, so what I'm doing now doesn't make much sense. You will probably have it in Rhino already, no, sorry. But just to get the idea, here's where solids could be a mesh. I think that could work, or you can convert it into mesh in Rhino. Let's see if that works. 3D print file. And again, ideally, because she made this in Rhino, you would 3D print directly from Rhino. You don't have to bring them again from Revit. It's kind of like a, doesn't make much sense.
So it doesn't matter that I don't know the placement of them exactly. I can just kind of put them into the floor plate.
I mean, they're going to print separately anyway. So when you have your floor plate, you know where they go. You know your plan.
Yeah, I guess nothing's like broken.
Well, it's a good point, because what if you have a floor here, and then how do you put the piece? If it's a single piece, you can't break through the hole. So you need to figure out how do you 3D print, so when you bring them in, they lock in or something properly, no? You know what I mean?
I think all of them sit on the floor except for one, which is supposed to be hanging. You can have it. Yeah.
So let's import it. So everything is the same. Again, this is kind of weird. You wouldn't normally bring something from Revit, because the complex thing that you did was probably done in Rhino or in other softwares. Yes, it's not coming for whatever reason. Do you have the Rhino file you can share with me?
Yeah, I'm opening.
Well, I might have something from you. Let me see if I have it already here. Let me try this because I actually. Okay, I have these monsters here. I'm just cooking there.
Oh, look at this.
Okay, so this, I mean, these are things that you did a long time ago, and probably they're not even correct now. Remember when you started this business? So, okay, this is a very old project model by Sarah, and she was using what is called sub-Ds. Okay, so those are sub-D tools. This is quite new for the Rhino now. And basically what you do is organic shapes and so on. Imagine you want to laser cut one of these guys, 3D print, sorry, one of these elements. Well, we need to prepare what is called a mesh to 3D print. I would probably do the opposite, the same as we did with laser cutting. So basically hide or delete anything that we don't need. I'm just gonna do an example of one. Doesn't matter where they are, because then you're gonna fabricate them and place them where they should. And then the rest that is not 3D printable, you're gonna, I'm gonna bring two so you know the process as well. Let's bring this monster too. So you, in Sarah's case, but she will have several pieces. Maybe you have only one, whatever it is.
Do we want nerves or?
Yeah, so let me go to that point. These are right now, you can go to the properties and it says, these are polysurfaces. This means that they're meshes, okay? And this is an open polysurface. So this is because it has the problem that you had back in the time. So in theory, okay, so things to think about. How big is the model gonna be? If it's gonna be a very big model, you might want to have the shell of the walls, meaning the thickness of the walls, no? If it's a small model, you can 3D print this as if it was all thick inside, all material, no? And you will.
Whether that will be hollow or whether that will have like
if
solid.
it's hollow or not depends on the scale. I wouldn't try to make it hollow if it's a 3D printed model of this. But if you're doing something like this, I would definitely do it hollow, and I would also chop it into parts that can come together. Let's just imagine, because the simplest thing is to think of it of a small scale that is all fill. That's going to be the easiest thing to 3D print. And this is one of the cases. What you need in general is a mesh. A mesh is a polysurface, which is this guy. If you have a NURBS, I'm not just, this is like a class on NURBS versus whatever. NURBS are the basic geometry or the most kind of numerically driven geometries or mathematically driven. This is a sphere. If you mesh it, this is a mesh, it turns it into a number of polygon surfaces that tries to equate to the sphere. No? Now meshes are made of polygons, and as you can see, they're flat here. So there's not a perfect sphere, which is something that simulates the sphere. When I mesh this sphere, I told it to have very little polygons or many polygons, and that's something to consider. The less polygons, the less accurate is the smoothness of that surface or the accuracy of it. No? So this has many polygons, it's more accurate. It just is heavier file, it will take longer to 3D print and so on. In general, we need this world of meshes to 3D print. You need a mesh. You can't do it with this guy. Well, you can have a NURBS and then just convert it. So this is already a mesh, okay? How do you know? Because polysurfaces are mesh, and because while you were working on it, probably you messed it up. You did a mess or something like that. And also, if you do a mess, you can do with many poly surfaces or less. If you want it very smooth, then you will add many surfaces, many polygon, or very little, and that will influence also, you know, the smoothness of, for example, on the top. The smoother it is the surface. Now, if it's a small model, you're not gonna really see those details, but if it's a very big one that you wanna add, so that again, scale matters quite a bit. Okay, so now there's the whole thing of, okay, let's think of the scale. The scale is the same. You're gonna have to scale this the same way we scale the line drawings in the laser cutting. You're gonna click and you say 0.00, whatever it is, and you're gonna have a small element that is precisely the scale that you want. I'm just gonna do it manually now, but remember that you have to calculate that number with a simple division. Okay. I'm gonna do those, and I'm gonna imagine this is the other one. Okay. Okay, so we have these two guys, and we want to 3D print those. The way it works, normally you will have to do some checking that is correct. It's a little tricky, but under mesh tools, which are here, you have the check object. You select it. It basically takes you if it's a good mesh or not. And it's a little dummy. You have the kind of mesh repair wizard. This is to help you fix the mesh. If there's any problem, you say check mesh, select it and enter. And it tells you, hey, this is a good mesh. You're lucky, good. You can 3D print. And if it's a bad mesh, you can start saying, hey, repair the mesh. Okay. What problems could you have as a mesh? Why wouldn't be able to 3D print? Well,
Has a hole on it.
has a hole on it. So it has to be watertight, is the famous term. If I delete this face, in theory, that would be a problem. Now, I think they have been, the machines are getting smarter and smarter, and this type of operations or openings are not problematic. So, but I would try to avoid having those problems. Why? Because, you know, a machine can tell that you don't really want something. What it does is it make a hypothesis if there's a problem. And I think here the hypothesis quite, you know, makes sense because it's like, okay, this lady wants a sphere, no? But if it's a more complex geometry, maybe those type of hypotheses become problematic um, for the machine. So you definitely want it to be watertight. And then there are issues of, you know, how big things can be, how small things can be, etc. And that's more of understanding what are the machines that we have here and what can they do. Okay. And that's more about talking to the experts on the machines that we have and see what they can do. I would just think that for all of your pieces, they can do it. There's no problem. Another issue is like how big is the volume of 3D printable possibility, you know? So one way you can check your boundary box, it's called, is to do that boundary box in Rhino and say enter, enter, enter. And what it does, it gives you a box that contains exactly your piece. Okay.
So, what
Bounding
is the
box.
limit of, like, you know, on the laser cutting, like there's a sheet that's the limit, but here, like, what is the size that?
You go to the machine,
It's pretty teeny.
and the machines are depending on the machine. There are like several machines, but I think it's like a foot and a half. You know, so they will tell you as this inches by this inches by that, those inches, and then
So I think we need to, if we are doing both of them, we need to set this first before we can set the scale of the building, because we could actually be on a bigger scale for the building at this point, right?
yeah,
Or we can cut it into 4 pieces and then.
you definitely need a strategy for the scale beforehand.
Same as
The
the
same, you just scale the thing as we did. I did it for scale, and then you say 0.05 comes down. So it's a scale like in AutoCAD in a way. Now, to get the dimensions, of the box, you would just go to the drafting, and then you can say, you know, horizontal dimensions here is this, and it gives you those dimensions. So you basically can you can study how big it is, and then say, well, this is way too small, too big. You know, you need to measure all the variables that the scale value gives you. Now you can always chop this in two and print one big. I mean, thinking of the box of the volume of the box of the 3D printer and saying it's small is not so true, because models that we do are not like huge either. So we can do a lot of things with that volume, but you could always 3D print half of one thing and another half, and then put them together with the glue or whatever it is. So there are many options that you can use to do what you want to do.
So what if like the thing has openings? Do I just like fill it and then cut it out after?
Well, I would go with the mesh tools, the repair wizard, check mesh, and then you will click here repair, and I will go through the process. There's a click, 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 and try to repair. And most of the times it just does it. The machine does it, but other times, let me see if it works here. I'm gonna delete this. It will even say it's okay, but it pops up this wizard. If you go to next, it will tell you, for example, one is open. So this edge analysis, it will show you naked edges. And naked edges means, hey, there's no surface next to this line, no? So you can zoom to it. It tells you, hey, you have a problem here. And then you need to know a bit more of how meshes work. And that's under mesh tools. You can just close these guys here is fixing problems, no? So one is rebuild mesh, but you have the build mesh hole. You can click there and click on the line, and it closes. Doesn't matter if it's a diagonal, just close it.
So it doesn't matter for my model if there's openings or not. Like it's just gonna be like volumes
If it,
in space.
I mean, if you did an offset of the surface, hopefully there's no big problem. But if you have any problem when you're doing this, let me know, and I'll sit one-on-one. But in theory, if it tells you here is a good mesh, you should be in good shape. Okay. Anyway, it is next. You can do fixing problems. You can fill holes here. You can do split edges. So there's a bunch of things that you can do through this system. You will solve your problems. Okay. Now, then the last step, again, your scale is correct. You know, you check the mesh with the checking option, and it says it's a good mesh, so you're happy about it. The next step is a very simple one, is say file export selected, and then there's a STL. Here's to the graphic. Okay, so that's the element that you want to save it to. Hello. Okay, now that basically does what it does is a simple mesh. It does a mesh, but because you have a mesh already, you're good to go. You take it to the machine. Now it's not an easy thing. We can jump into the machine and in the lab now and talk about how the process is. What I would do is ask for help from the workers that are there at different times. But what they do is use a slice. I don't know if it's good. Because I have the program, but I haven't used it in a while. See if I find it. So yeah, the Ultimate Cura. Yeah, sorry. I downloaded for free this software. It's called Ultimaker Cura, and this is what they use over there normally. Okay, so it's what it does is slice this automatically for you and prepares the 3D file. So again, the first time you prepare this is going to be a pain. The second one is also going to be a pain, and the third one too. But the fourth one is still going to be a pain, but the fifth one, it's going to be smooth and nice. So
58,001, you get it.
okay. So this Kura is like this. And what you tell here is what machines they have, and the name it's in the machine. You say, hey, I think it's the Prusa IE3, and it gives you a preview of the machine. This is the bed, and this is the volume. No? And what you do is basically import elements. So you will click here, and then you select the stereographic, the one that we say from Rhino. It will come here. I haven't checked the scale, so it might be huge, and it might say, you're ridiculous. It's not even doing it.
Maybe it is there. It's like
Oh, it's a
really
cute.
tiny.
So that's a problem. So you see, it's so small. So let me fix it. Let me do this scale 10 times bigger.
So when we import it, it has to be a real scale.
The scale of the 3D printer, yeah, makes sense, huh? So we're gonna do export selected again. STL, hello, save, override, yes.
Go back to
Wait, say okay. Go back here, folder, see how. There you go.
Oh, still pretty tiny.
Yeah.
And you can't change the scale in Ultimate Cura. You have to have it.
No, it makes sense that the only one is only helping you to 3D print. It makes sense that you make this decision here in Rhino. No? I don't know if 10 is going to be too much now. So let's do 3 times. I don't know why I'm saving that. I shouldn't have. Anyway, whatever. Export selected. Hello.
Test printed.
And then bring it again.
There you go.
Okay.
Still pretty small.
Okay, but it does the job. What are we talking about? No. Okay, so how do we go about it? Basically, you need to tell a couple of things. Here is like the settings for slicing. I would just leave some of the automatic settings, no? So you have
And what
here.
if you want to like make the same like two things? When you have two of them in your
You can do,
Rhino file, and then
you can have them here all together because you can bring one by one and move them.
okay, or you
So-
can have like 5. But
And you
would
can,
it just print one thing at one time? Obviously.
it will go from the bottom and then slice upwards. So it means it will start the first bottom line of one of the pieces, then it will jump to the bottom line of that one, the other one, the other one, the other one, and then
Oh,
add. So, but you can go one by one because it would just be an issue of time. No. Now, if you put here 10 pieces, and then one of them fails, and the other, you have to cancel the whole thing. So maybe,
It's very
and
good.
and to be honest, it kind of fails quite often. So I would be careful. So you will choose one of these options. Maybe fine is good, and then just leave those. The support means if your geometry has a very kind of a cantilevering geometry, it needs some support. Otherwise, it will just fall. There's also logics, as in the best ways to put an object. You will try always to avoid cantilevers as much as possible. So if you have, imagine a tree condition that's going upwards, I would put the tree upside down. So you 3D print the base first and then the trunk. No? This is an example. I wouldn't do the opposite because then it goes with the trunk. A lot of support to hold the 3D printing of the top. So I would always think twice about how do we organize the piece so it doesn't have support. Now, if you really need support, you have it. You always need adhesion. Adhesion is basically a surface that creates on the bottom so it doesn't really float out of the bed. It's basically, it warms up the base so it just doesn't move while it's 3D printed. Okay, you can do custom settings once you're an expert and so on, but probably one of the basic settings is good. And then you slice. What it does is basically cut the thing. Okay, you can preview this and it shows you the different slices. You can even see how it's going to be 3D printing. I'm gonna do, see if it does it or not. It should be. Maybe so small, but this is the base, and you see those little guys there? Those are support because it's rounded on the bottom. You can't just 3D print from the base and then go out because that will fall apart. So you need some base there to do it. So it will calculate those things.
They will make that themselves. You don't have to make the support thing. So it kind of like,
That's calculated automatically, the support material. Now, normally you will be able to see the way the machine goes. I don't know why it's not happening here. Maybe because I'm sharing. Oh, there it is. See this guy? He's only telling us the last part. Anyway, it's a preview. And then you need.
tell you that it's going to take 38 minutes to print.
Yeah, this is the timing. And this is a small piece. I mean, it makes sense. It's pouring in material and it's going upwards. So some people leave it during the night and you go to sleep and the morning after it's ready. And then you find it didn't work.
3 days max usually.
Yeah.
Put it on a night.
Okay. So the last thing is that you need to save it to a disk. So this step, I mean, I have a way to save this, but if you don't have, the disks are very small memory cards in their blue color that they're all there. You can take one from the fabrication lab and then you save it there. Maybe you can ask one of the workers there, hey, can I save it to a disk with your computer? And then you will save it there, no? And that's the element. We can go to the fabrication lab and take a look at that now. So this is the preparation of the 3D print with the Cura. There are other softwares. Yes, Asma.
I usually see people create it in different colors. How does most work?
Different colors, different materials. These are very simple machines. Each machine, for each machine, you can place a different material. So you could.
How to show the program that I have different colors?
Yeah, the fabrication lab will have a couple of materials that they can use. And normally they have the white material and then a transparent one. But if you want other ones, you can ask them if they can purchase for you, or maybe you're gonna need to purchase filament, it's called. Now, because they're big rolls, you probably don't wanna buy a new roll for yourself only because you're not gonna, it's gonna cost money and it would be to do, I don't know, 50 different projects. So unless you have some friends that they all want to 3D print and you want to spend the money on that, or the school might be able to do it, but I'm not sure. I know the school has the standard filaments and you're free to use those. And I think they're in white. Filament is good material, but if you want different materials, then you might need to spend some money on other type of filaments that are more sophisticated. And you have all kinds of materials. You have transparent, translucent, red, shiny. So there's all kinds of metallics, and you have fluorescent. There's a bunch of things out there.
My question is how to send the order to the machine that I want this color in this spot and that from that one.
Yeah, you're not going to be able to do that with the machines that we have here.
Oh, okay.
Those are very sophisticated machines that they're quite special. So the ones that are here is one filament, one machine. You know what I mean?
Mm-hmm.
Yeah.
I have another question for laser cutting.
Yeah, let me finish this and then I jump.
Okay, sure.
So that's the process for 3D printing. Okay, let me stop sharing, stop recording.